Hello everyone, in this video we're going to learn how to find the n-parameter family of solutions and general solutions to the differential equations. You know from your experience in previous mathematics course that the calculus of functions of several variables like limits, graphing, differentiation, integration, and applications is more complicated than the calculus of functions of a single variable. By extensions, therefore, you would expect that the study of partial differential equations would be more complicated than the study of ordinary differential equations. This is indeed the case. In calculus, you learn that not only is each member of the families y equals f of s plus c is a solution of the differential equation, but this family actually represents the set of all solutions of the equation. That is, there are no other solutions outside of this family. Alright, so let's take a look at the following examples. First, we need to find the one parameter family of solutions of this differential equation. So which means we need to find this guy right here equals how much. Alright, so basically we just integrate this one. In other words, we need to take antiderivative of these guys. Alright, so I'm going to take antiderivative of this guy. It turns out to be the integral of 2x minus sine 2x ds. So it turns out to be 2 times s squared over 2 minus, now you need to integrate this one, it turns out to be negative 1/2 cosine 2x. Alright, don't forget the constant at c. Alright, now I'm going to simplify 2 and 2's gone. So I have s squared, negative turns out to be positive 1/2 cosine 2x plus c. And this is the answer for the example number 1. If we want to show the family of solutions of differential equation, we're going to use decimals, right, to wrap this one. So we have y equals s squared plus 1/2 cosine 2x. Now, if you look at this guy, you see that it's going to be plus the constant. So you just let the constant equal 1, 2, 3, something like that. You will have the family of the solutions. So add 1, I get this one. Now I do the same thing for the second one, but I'm going to add 2. Alright, so I keep doing this one. I'm going to add 3. I keep doing this one. I'm going to add negative 1, something like that. Alright, so you see that these guys right here are the set of all solutions to the differential equations. Alright, so if you let c equals 1, for example, alright, so if I let c equal 1, I have s squared plus 1/2 cosine 2x plus 1. This is called particular solution to the differential equations right here. Particular solution is going to be like this. If specific values are assigned to the arbitrary constants in the general solution of a differential equations, then the resulting solution is called a particular solution of the equation. So if you look at this one, so this guy, the first one right here, is a particular solution, which means the green one. So I don't need this one anymore. This is a particular solution. Alright. Let's move on to question number 2. Find the two parameter family of solutions of differential equations. So this is tridifferentiable, right? We're gonna take antiderivative of these differential equations twice. Alright, so we're gonna take antiderivative of this one the first time. So it's gonna be antiderivative of 6s plus 4 times e to the 2s. Alright, ds. It turns out to be 6 times s squared over 2 plus 4 times 1/2 e to the 2s plus c1. Alright, now we're going to simplify this one. So it turns out to be 3s squared plus 2 times e to the 2s plus c1. Now next one, we're going to take antiderivative of this one more time. So it turns out to be this one ds, right? So it's going to be 3 times s cubed over 3 times 2, plus times 2 times 1/2 e to the 2s plus, this is a constant. So when you integrate this one, it turns out to be c1s plus c2. Alright, where c1s and c2s are arbitrary constants. Alright. So we're going to simplify this one. It's going to be s cubed plus e to the 2s plus c1s plus c2. And this is y. This is the final solution. Now let's move on to question number 3. We need to show that y equals c times e to the ks is a one-parameter family of solutions of differential equation y prime equals k times y. So now we have this equation right here, okay? And we need y prime. So we have y right here, okay? So we take the derivative of this one. So we have y equals c times e to the k s. Now take the derivative. So it's going to be y prime equals k times c e to the k s. Now we substitute this guy back over here. Alright, and we need to prove that two sides are the same. Alright, so we have k times c times e to the k s equals k times y, k times y, but y equal this one. So it's going to be c times e to the k s. Alright, now we need to prove that if both sides the same. Alright, so this one and this one, we observe that they're both the same, right? So we can conclude that this guy right here is a one-parameter family of solutions of these differential equations. Alright. Now let's move on to example number 4. We need to show that this equations is a two-parameter family of solutions of these differential equations. So we see that this is two-parameter and this is tridifferentiable, right? Y double ramp right here. So we need to take derivative of this guys twice. Alright, so I have y equals c1 s squared plus c2 s plus 2s cubed. Okay, so y prime is gonna be 2c1 s plus c2 plus 6s squared. Now second derivative is gonna be y double prime is gonna be 2c1 plus 12s. This guy derivative equals 0. Okay. Alright, now I'm gonna substitute every single thing right here into this equation and verify if both sides the same. So I have s squared parenthesis times y double prime. Y double prime is gonna be right here. So it could be 2c1 plus 12s minus 2s parentheses times y prime. Y prime is going to be 2c1s plus c2 plus 6s squared plus 2y. So plus 2 times this one right here. So it can be c1 s squared plus c2 s plus 2s cubed. Okay, so I need to verify if this one equals 4s cubed. If it's equals, yes, this is the two perimeter families of solution. So I'm going to distribute this one. So it turns out to be 2s cubed c1 plus 12s cubed minus, this is c1. It's not 4. So it could be 4 c1 s squared minus 2c2 s minus 12s cubed plus 2c1 s squared plus 2c2 s plus 4s cubed. Alright, now I'm going to simplify 2s squared c1. This is negative 4c1s squared. And this is 2c1s squared. So this guy, and this guy cancel out. Now 12s cubed and negative 12s cubed cancel out. This guy and this guy cancel out. We only have 4s cubed left, which is this guy right here. Alright, so this guy has been verified. So this guy is a two perimeter families of solutions to these differential equations. Alright, let's move on to question number 5. Alright, we need to verify that this guy is a general solution to this guy. Alright, so this is very simple, right? This is similar to number 3 and number 4 right here. Alright, so I leave it for you as a practice. Alright, we're going to move on to number 6. Find the particular solution to the differential equation in example number 4. So example number 4, this is a general solution, right? So I write it over here. C1 s squared plus C2 s plus 2s cubed. You need to find the particular solution to the differential equations. We need to let C1 be any number. So I let C1 be 5. I let C2 be 4. So I substitute back over here. So I have y equals 5s squared plus 4s plus 2s cubed. This is a particular solution to the differential equation right here. So we have infinitely many particular solutions to the differential equations. And this is a general solution to the differential equations. Now, let's move on to question number 7. Now, let's move on to the question number 7. We need to find the differential equations for the family to the one perimeter family right here. Alright, so basically we have y squared equals c s cubed plus 3. Alright, we need to take derivative both sides. So we have 2y times y prime equals 3c s squared. This guy's derivative equals 0. Alright, so I need to solve for c. So I have c equals 2y times y prime divided by 3s squared. I substitute back over this equation. So I have y squared equals 2y times y prime over 3s squared times s cubed plus 3. Now we need to simplify this guy and this guy, so it turns out to be y squared equals 2y y prime over 3 times s plus 3. Now I'm going to multiply both sides by 3. So it could be 3y squared equals 2y y prime s plus 9. Alright, now I'm going to subtract 9 both sides. So it could be 2y y prime s equals 3y squared minus 9. And divide both sides by 2sy. So it could be y prime equals 3y squared minus 9 divided by 2sy. And this is the differential equation that we need to find. Alright, let's move on to question number 8. Find the differential equation for the two-parameter family y equals c1 e to the negative 2s plus c2 e to the 4s. So I have y equals c1 e to the negative 2s plus c2 e to the 4s. Now I need to take derivative both sides, so it's going to be y prime equals negative 2 c1 e to the negative 2s plus 4 c2 e to the 4s. Now second derivative, because the question say two perimeter. Okay, so I'm going to take the second derivative, so it could be y double prime is going to be 4 c1 e to the negative 2s plus 16 c2 e to the 4s. What we need to do is to solve for c1 and c2 from the first two equations right here. And then we substitute into the third equation, we get the final equation. Alright, so in order to solve for c2 in these two equations right here, I'm going to multiply the first equation right here, both sides by 2. Alright, so I multiply both sides by 2, 2, and 2. So what do I have? So I have 2y equal to c1 e to the negative 2s plus 2c2 e to the 4s. Now I rewrite the second equation, so it can be y prime equals negative 2 c1 e to the negative 2s plus 4 c2 e to the 4s. Alright, now I'm going to add them up. So does that mean this guy cancel out? So I have 2y plus y prime equals 6c2 e to the 4s. Now I need to solve for c2. So c2 equals, divide both sides by 6 e to the 4s. So it could be 2y plus y prime divided by 6 e to the 4s. Alright, next one. I need to eliminate c2. Alright, so I need to multiply the first equation both sides by negative 4. So I have negative 4 right here, negative 4, and negative 4. So I have what? Negative 4y equals negative 4 c1 e to the negative 2s minus 4 c2 e to the 4s. Alright, I rewrite the second equation. So it can be y prime equals negative 2 c1 e to the negative 2s plus 4 c2 e to the 4s. Alright, so this guy cancel out. Add this guy up, it turns out to be negative 4y plus y prime equals negative 6 c1 e to the negative 2x. Now I need to solve for c1. So it could be c1 equals negative 4y plus y prime divided by negative 6 e to the negative 2x. I'm going to print this guy and then this guy. I substitute back into the third equation right here. So what do we have? So I have y double prime equals 4 times c1. c1 equals this one. So it could be negative 4y plus y prime over negative 6 e to the negative 2x times e to the negative 2x plus 16 c2 equal this guy. So it could be 2y plus y prime over 6 e to the 4x times e to the 4x. Alright, now I just simplify. This guy cancel out. This guy and this guy cancel out. So I have y double prime equals, I'm going to simplify this one. So I have, this turns out to be 2. This guy turns out to be 3. So I have 2 times negative 4. It could be negative 8y. 2 times y prime plus 2y prime over negative 3 plus this guy and this guy cancel out. So it could be divide the top and bottom by 2. So it could be 8 and it could be 3. So I have 8 times 2. It could be 16y plus 8y prime divided by 3. Alright. Now I need to multiply both sides by negative 3. So I have negative 3y double prime equals negative 8y plus 2y prime minus 16y minus 8y prime. Alright, now I need to simplify this one, so it turns out to be negative 3y double prime equals this guy and this guy is going to be negative 24y. This guy and this guy turns out to be negative 6y prime. Now I need to add 24y and 6y prime both sides, so it turns out to be 24y plus 6y prime minus 3y double prime equals 0. Alright, divide both sides by 3, so it could be 8y plus 2y prime minus y double prime equal to 0. This is the final solution. Alright, question number 9 and number 10, similar to question number 8. So I leave those questions for you to practice, and please leave the answer in the comment. And it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you're failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.